Progress check number 4, geometry for GCSE Maths Higher. Question number 1. The diagram shows a sector of a circle, so it's not a full circle as we can see. The arc length is 47.6 centimeters. This is the arc length. And it is 47.6 centimeters. The radius to the nearest whole number is 13 centimeters. Is this statement true or false? So this statement here, we've got to decide whether it is true or false. So we'll start from the beginning. To work out the length of an arc, we would write the number of degrees of the angle, which is 210 in this case, and that is out of 360, which is the full circle. Then we'd multiply this by 2 pi r, so we'd have 2 pi r, and that is equal to 47.6 in this case. We know there's going to be multiplication between these numbers and symbols. So we'll get a calculator out to work this out. And we'll input 210 divided by 360, which is 7/12, so we can keep it as a fraction for the time being. There is no problem with that. Now, as you can see, we can multiply in here, so we're going to multiply it by 2. So times 2, and then pi, which is 3.142 approximately. And then we'll multiply by the radius, but instead of multiplying this by 13, I'll be interested to work out what r is. Is it 13 to the nearest whole number? So we'll go down that route. So we'll leave this as it is, so we're not going to multiply the answer by r, the radius. So that's what we have so far. And so this number multiplied by the radius should give us 47.6. So what we're going to do is we're going to divide 47.6 by this number and see whether that gives us the radius being approximately 13. So we'll sort this as the answer. And I'm going to do 47.6 divided by the answer, and it gives us the radius, which is 12.98535,964. So rounded to the nearest whole number, this is 13. So we found out that the statement is true. So we're going to select true. In question number 2, you've got to describe fully the single transformation which maps triangle T to triangle U. Question 2a, so this is only part A. In this response, just give the type. Example, rotation, enlargement, reflection, or translation. Could this be rotation? If you think of triangle T being rotated to come to this point, we would have a smaller triangle, so the same size as triangle T, if this was rotation. So we'd have something like this over here, and that's not the case because triangle U is bigger. So this is not a rotation. Is it a reflection? Can this be a reflection? So if triangle T was reflected maybe on the line minus x equals y, or y equals minus x, then this would look, it would look slightly different. So you'd be like a mirroring line, more or less, something like this. So we'd have a smaller triangle reflected on the other side, and that's not the case. Besides, the triangle is larger, so U is larger. So this is not a reflection. So no rotation, no reflection. Could this be a translation? Again, with translation, you'd have exactly the same size as the triangle, and you'd be moved to different places. So maybe it looks something like this or here. So this is not a translation either. So it is an enlargement. The size of the triangle has changed, so it is an enlargement. Even if it's got smaller, we call it an enlargement. So we'll write enlargement here. This part links to the same question, so we're going to have to write just a scale factor in this one. So as we decided earlier, this is an enlargement. Now the reason why we can see the shape being flipped is because this is a negative enlargement, and we'll see what that looks like when we work out the factor. So we'll pick similar corners. So this one is being presented here in the shape, so we're going to get a ruler out. So we're going to find the center of enlargement at the same time as the factor. So we'll connect these two together by drawing a line, and then we have this corner being shown here. So we'll connect those two together. And finally, this right angle is shown here. So as you can see, we've found the center of enlargement, which is this point. So the point -2, -2. And in terms of the scale factor, what we can see is that this has gone, this length here, for example, is represented here. So it's gone from 2 squares, it's gone to 1, 2, 3, 4, half here and half here. That makes another full one, so that makes it 5. So it's gone from 2, it's gone to 5. And the same thing is happening in the other one. So if you look at this length, which is represented here, it's gone from 1 to 2.5. So as you can see, 1 is multiplied by 2.5 to give us 2.5, and 2 is multiplied by 2.5 to give us 2.5. So we're talking about 2.5. But as we talked about this earlier, this is a negative enlargement. As you can see, we have this dot in the middle, so we've got the shape changing position, so it's flipped. For that reason, it's a negative enlargement, and the scale factor is minus 2.5. So we'll write minus 2.5 here. In this part, we'll only write the center of enlargement, which we worked out just now. So minus 2, comma, minus 2. In this question, we've got triangle A is reflected in the x-axis to give triangle B. So we'll show that, we'll action it. So there is the x-axis. So it's being reflected on this. So we'll have, there is a gap of 1 squared c, so I'm going to give 1, and same on the other side. And this is 3 squares high. Join them two together, ideally with the ruler. So this would be triangle B. Now we've got triangle B is reflected in the line x equals 1 to give triangle C. So where is x equals 1? There is x equals 1. This is also 0.12. This is 0.14, and so on. So this is the line x equals 1. Now, triangle C is the reflection of triangle B in the line x equals 1. So we have 1, 2, 3. So we have 1, 2, 3 as well. And we're going down by 3 squares. We're going to the right by 2. So this is triangle C now. Now what we're going to find is the single transformation which maps triangle A to triangle C. If you look at the two shapes A and C, it does look like this is a rotation based on the position that they have. So it's not any reflection. So this is not true. It's one of those other three. Is it a rotation by 90 degrees or of 90 degrees? If it was a rotation of 90 degrees, we would see shape C either here or in this other quadrant, and that's not the case. So this is not true either. It's between B and D. Now, B is saying rotation of 180 degrees around the point 0, 0, so the center. And if we look at this, and shape A was rotated 180 degrees, then shape C would be closer to the center. So that is not the case. Looking at option D, we've got a rotation of 180 degrees around the point 1, 0. So this is the point 1, 0. And we can show it in a different color perhaps. So there is 0.10, and as you can see, the distance between A and that point is the same as the distance between C and the point. So this is a rotation of 180 degrees around the point 1, 0. So in question number 6, we've got in the diagram A, B, C, and D are points on the circumference of a circle, center O. Angle BAD is equal to 55 degrees. Angle BOD is X number of degrees. Angle BCD is equal to Y number of degrees. Work out the value of X. You do not need to write the units. So, looking at X, and we already know that this is 55. So this is angle at the center, and this is angle at the circumference. So based on the circle theorems, this is one of them, so which says that angle at the center is twice the angle at the circumference. So this is going to be 110 degrees. So we don't need to write the degrees, just the number 110, as we're told that here. In this next question, we've got to write the reason for the answer that we've just picked. So that was angle at the center of a circle is twice the angle at the circumference. So it's option C. In question number 8, we still have the same diagram. Now we've got to work out the value of y. So that is this angle in here. We can see that there is a cyclic quadrilateral, which means a quadrilateral with all of its angles lying on the circle. So you can see all 4 of the angles lying on the circle. So there is a theorem for this which says that opposite angles add up to 180 degrees. So 55 and y are opposite each other, so they must add up to 180. So to work out y, all we're going to do is 180 take away 55, so there is the 5, 2, so 125 degrees is y. Now we have to give a reason as to why we decided that y was equal to 125 degrees, which was C, because opposite angles in a cyclic quadrilateral add up to 180 degrees. In this question we have P and Q are two geometrically similar solid shapes. The total surface area of shape P is 540 centimeters squared. The total surface area of shape Q is 2160 centimeters squared. The volume of shape P is 2700 centimeters cubed. Calculate the volume of shape Q. You do not need to add units in your answer. So we're looking at similar shapes. I'm gonna illustrate with an example what happens when you enlarge a shape. What happens to the surface area? What happens to the volume? So I'm gonna pick a cube with dimensions of 3, 3, 3 centimeters. And next to it, I'll put another shape with dimensions 6, 6, and 6. So length, width, and height would be 6. Let's call them units. At the moment, it doesn't matter whether it's centimeters or meters or kilometers or whatever. So we can see that the dimensions have changed. So the length has gone from 3 to 6. So length has doubled. So the scale factor of enlargement is 2. Now, what's happened to the area? If you look at just this face and this face as well, so this face here is worked out by multiplying 3 by 3. So 3 times 3 is 9, but 6 times 6 is 36. So the area hasn't doubled. In fact, has been multiplied by 4, which is 2 squared. Let's see what's happened to the volume. For this one, it is 3 times 3 times 3, which is 27. Whereas for this one, it is 216. So 6 times 6 times 6 gives us 216. So what do we do to 27 to get 216? What do we multiply it by? So 216 divided by 27 is 8. So the volume has been multiplied by 8. In other words, the volume of the bigger cube is 8 times the volume of the smaller cube. And 8 we find by cubing it, by cubing 2. So 2 times 2 times 2 gives us 8. So if the length is doubled, then the area is multiplied by 4. So 2 squared. The volume is multiplied by 8, which is 2 cubed. And you can remember these because the unit for area is centimeter squared or meter squared, and for volume is centimeter cubed or meter cubed, and so on. So now let's suppose that this is shape P and this is shape Q. We do not know the dimensions, so we're going to take these off. So I'm going to take the dimensions off for both of the shapes. And what we know is that the surface area, so we're looking at area of P is 540. And of Q is 2160. So if we find the scale factor for the surface area, then that's going to help us with the next steps, because we need to look at volume. By dividing 2160 with 540, I get 4. So 540 times 4 gives us 2160. Now, this tells me that the scale factor, which is for the length, is going to be 2, because this is equal to 2 squared. And as we said before, we square the scale factor in order to find out what number the area has been multiplied by. So this is 4. So the volume is 2 cubed, which is going to be 8. So the volume of the smaller shape will be multiplied by 8 to give us the volume of the bigger shape. The volume of the smaller shape is this, which is 2700. So 2700 times 8 gives us 21,600. And this is the answer. And we do not need to include the units in this case. Now in this question we have a triangle. We've got to find the missing length, which is this one, x, and give the answer to 3 significant figures. So when we have right angle triangles, we're dealing with Pythagoras or SOHCAHTOA. When it's non-right angle triangles, then we're looking at the sine and the cosine rule mainly. So we have this triangle here, and we can see that we have 2 angles given and 1 length. We know that Sine's rule looks at the lengths opposite the angles. So we're looking for a length here and a length here. Now we can see the x in there, but there isn't anything in here. So what can we do in this case? Given that we know that there are 180 degrees in an angle, we can use that information to find the angle here. So we've got 50 and we've got 71, which makes 121. If we take it away from 180, that is going to give us 59. So we know that this angle here is 59 degrees. In this way, we have 2 sets of angles and lengths opposite them. So we have this one, the 71, and x opposite it. But we also now have the 59 and the 12.6. The sine rule goes sine of A over A is equal to sine of B over B and sine of C over C. Or you could have them as A over sine A is equal to B over sine B equal to C over sine C. This is the lowercase c. So A or B or C could be any of these. We just know that the lowercase ones mean the lengths, and the capital means the capital letters mean the angles. So if we say that 59 is going to be angle A, then 12.6, which is opposite it, will be the length A in lowercase. And if we say that 71 will be angle B in capitals, then X is going to be side B in lowercase. So we'll write this as A, lowercase a, which is 12.6, divided by sine of 59 degrees is equal to x over sine of 71 degrees. Now with this, there are different ways you could do it. So you could divide 12.6 by sine of 59 and then multiply by sine of 71, or just go straight into multiplying sine 71 by 12.6 and divide by sine 59 in a calculator. Whichever way you use, that should be fine. I'm going to use the latter to make my life easier, so I will go 12.6 times sine of 71, close the brackets, and then divide by sine of 59 degrees, close the brackets again, and that gives us 13.8987267, which to 3 significant figures will be 13.9. So we'll include it here. (13.9). We have another triangle question. The lengths of the sides of a triangle are 4.1, 5.4 and 7.8 centimeters. Calculate the size of the largest angle of the triangle. Give your answer correct to one decimal place. So we're looking at this angle. We need to find this angle which is opposite the largest length. That's the largest angle. Now, can we use the sine rule? We cannot in this case because we don't have any information about the angles at all. So we're going to have to use the cosine rule, which is c squared is equal to a squared plus b squared minus 2ab cosine c. Now we can rearrange this to get to cos c, so make that the subject of the formula. We could have it ready, so take it as it is ready and use it, or we could use the one that we have by rearranging the formula. So I'm going to just go and use this one that we have. So we've got to label these lengths and angles first. Since we interested in this angle and we're looking, the version that we have here is cos C, we'll label this angle as C, and this means that this is side C. The other two can be any of them, A or B, doesn't really matter. So now I can say that C squared, which is 7.8 squared, is equal to A squared, so 4.1 squared, plus 5.4 squared, minus 2 lots of A 4.1 times B, which is 5.4, multiplied by cosine of C, which we don't know at the moment. So we'll continue to work out what we know. 7.8 squared is 60.84, which is equal to 4.1 times 4.1 is equal to 16.81 plus 5.4 times 5.4 is equal to 29.16 minus 2 times 4.1 times 5.4 is equal to 44.28 times cosine C. So 60.84 is equal to 16.81 plus 29.16 is equal to 45.97 minus 44.28 cosine C. Now we can rearrange this to say that 45.97 minus 60.84 is equal to 44.28 cosine C. So we'll write this down. So minus 14.87 is equal to 44.28 cosine C. So cosine C will be equal to minus 14.87 divided by 44.28. So the cosine of C is equal to minus 14.87 divided by 44.28, which you can use a calculator to work out. And we know that this is the answer to the cosine of C, but we don't know what C is, what is the angle. So to do that, we'll reverse the process. So we'll use, rather than using cosine, the cosine button, we'll use this one at the top. So we'll click on Shift and then the cosine button, and you can see this minus here, which means the opposite of a cosine. So we'll have that and we'll input this, which is minus 14.87 divided by 44.28, closing the bracket, and that should give us the angle, which is 109.622589. We need to round this to one decimal place, so this is going to be 109.6. So that's what we write here, 109.6. We have another triangles question in here, which we're going to have to work out the area of. So the area of the triangle in centimeters squared. And since we haven't got a height being given to us and the base, we're going to have to use a different formula which links angles and lengths as well, which is half of AB sine C. So we'll label C as the angle between the two lengths that we know. As you can see, it's labeled as well. We'll need to work it out. So we've got an angle of 54 degrees and another which is 39. That is 93. Taking it away from 180, that leaves us with 93. So this is 93 degrees. Now we'll use the formula to work out the area. So the area is half AB sine C, half of A. Let's label A and B, so it could be any of these two. A, B over here, and this is C. So half of 23 times 31 times the sine of C. So half of 713 times sine C. We can use a calculator to get that. So we'll input it in the calculator. 713 times sine of 93 degrees, which is C. That is this number, which we then can divide by 2 because it's supposed to be half of it. So we've got 356.0114291, and we've got to write this correct to 3 significant figures. So the first 3 figures with the highest significance are 3, 5 and 6. This 0 here does not make this go up, so we're going to go 356. In this question we have, the diagram shows a box in the shape of a cuboid. AB is equal to 8 centimeters, BC is equal to 11 centimeters. A string runs diagonally across the box from D to F and is 18 centimeters long. Calculate the length of AE. So we're looking at working out this length, which is in fact the same as this one, or this one, or this one. I'm going to stick to this because there are different ways we can work it out, but I think this is one of the easiest. So I will take off the rest. Now we want to work out BF. What we know is AB and BC. So I'm going to use that information to get the line that runs diagonally and connects B and D. So I can use Pythagoras to work this out. So I will use the information that I have, because this is 8 and this is 11 centimeters. So to work this out, which happens to be the hypotenuse of the triangle, let's label it as n. So to work n out, we go n squared is equal to 11 squared plus 8 squared. So n squared is 185. So n is equal to the square root of 185. It gives a long decimal, so I'm going to keep it like that for the time being. Now, once I have this forms a triangle, a right-angled triangle with D, F, and B. So these points make a right-angled triangle. So F is here, we have D, and then we have B. So this is 18 centimeters. This is square root of 185 centimeters. So we've got to work out BF. So there is a right angle in here. So we'll get the calculator out to work this out, because we know that BF is equal to 18 squared, take away the square root of 185 squared. I'll write this down. So BF squared is equal to 18 squared minus the square of the square root of 185. So all of this is squared. But what happens, because square root and squared are opposite of each other, so what we have now is that BF squared is equal to 18 squared minus 185. So BF squared is equal to 324, which is 18 squared, minus 185. So BF squared is equal to 139. So BF itself will be the square root of 139, which is 11.789826126. To three significant figures, we have 1, 2, 3. So we cut it off here. So 8 makes the 7 to go up by 1. So this becomes 11.8. and we will not include the units. The diagram shows a wedge. The base of the wedge is a horizontal rectangle measuring 80 centimeters by 60 centimeters. The sloping face ABRS makes an angle of 21 degrees to the horizontal. Calculate the angle that AR makes with the horizontal plane ABCD. Give your answer to one decimal place. So we're looking at this angle here. Now, if we were to look at this from this position, what this is going to look like is very similar to this. So this is CR, and we've got B over here opening up, and on the other side we have A connected with R. So we know this is 21 degrees. We want to work out this one, which we don't know. We know that this is 80 centimeters long. We don't know how long AC is, but we know this is 90 degrees and this is 90 degrees. So to work out AC, we can use Pythagoras. So we could do AC squared is equal to 60 squared plus 80 squared. So AC squared is equal to 10,000. So AC itself is the square root of 10,000, which is 100. So this is equal to 100 centimeters. Now, since this right-angled triangle, this one, BRC is the right-angled triangle, we can work out using SOHCAHTOA this height here. So we know this 21, and we've got to work out the length opposite the angle, and we also know the adjacent, which is 80 centimeters. So we're looking for O and A, and that is this one, so TOA. So the tangent of 21 degrees is equal to the length opposite, which we don't know. So it's O for opposite rather than 0, divided by 80. So tangent of 21, we can work out using a calculator. To make this more accurate, we're going to say length of O is equal to tangent of 21 degrees times 80. So we'll input this in the calculator. So we find the tan button, 21 times 80, which gives us 30.7091228. So that is this here, this one, this length, which is in common for both of the triangles. So that was 30.7091228. we'll use the exact number now to help us work out angle A in here. So I'm going to use the same formula to work this out. So we'll go tangent of angle A is equal to opposite. So opposite was, the length opposite was 30.7091228, which I still have in the calculator, and should be divided by 100. So we can do that in the calculator. So tangent of A is 0.307091228, and we need to find the angle itself now because we know what the tangent is equal to. So dividing this by 100 gives us this. So this is, if we store it as the answer, we can work out the angle. And that is 17.07126286. We need to write this to one decimal place, so it's going to be 17.1. Express vector xy in terms of a and b. Choose all options that apply. So we're going from x to y. So we're going this way, then this way. Since going this way means we'd have to change the signs. So 2a plus b will become minus 2a plus b. And then we have plus 4a plus 3b. So we'll get minus 2a minus b plus 4a plus 3b. Minus 2a plus 4a will give us 2a. Minus b plus 3b will give us 2b. So we have 2a plus 2b, which is option B here. But we can also express this as 2 lots of a plus b, which is option D. We have another question on vectors that links to the previous one. So we've got to use the answer from the previous question to help us here. So we've got information which is x, y, z is a straight line. X, y to y, z is equal to 2, 3. So the ratio of x, y to y, z is 2 to 3. Express the vector OZ in terms of A and B. Give your answer in the simplest form. So we need to express this one here. So OZ, the vector OZ. We haven't got any information there, so we're going to have to go this way. From O to X, and then from X to Z. We know from the previous answer that XY is 2A plus 2B. So we'll need now YZ. We are given this information which gives us the ratio. So if XY is 2a plus 2b, then yz will be 3a plus 3b because of the ratio given. So this is 3a plus 3b. So now we can go from O to X, so 2a plus b plus 2a plus 2b plus 3a plus 3b. So we can collect the like terms. We have 2a and 2a and 3a, which makes 7a. We have b and 2b, 3b, and 3b, 6b. So 7a plus 6b is the correct option.